In early 2026, enterprise server backups started vanishing without triggering any error alerts. At the same time, hardware setups like 3D printing systems began locking up completely, with processors spiking to maximum capacity as mechanical arms froze. The cause of these widespread cascading failures was traced back to a single piece of software called Rsync. This is a 30-year-old utility that quietly handles data synchronization and file transfers across almost the entire Unix-based internet. Despite its massive global footprint, Rsync's maintenance structure is incredibly fragile. For nearly 2 decades, its absolute stability relied almost entirely on the meticulous oversight of a single human maintainer. When that maintainer stepped down in 2024, the project was left in a vacuum. Andrew Tridgetool, the tool's original creator, returned to resume stewardship. He inherited a massive backlog of unaddressed security warnings and a historical lack of community contributors to help process them. That extreme centralization set the stage for a systemic crisis. Facing an unmanageable wall of maintenance tasks and human burnout, Tridgetool turned to generative artificial intelligence. He partnered with Anthropic's Claude to autonomously co-author code and rapidly accelerate the update cycle. This experimental collaboration was suddenly forced into high gear by the discovery of CVE 2026-29518. This was a high-severity security vulnerability that demanded an immediate, rushed patch. Fixing this flaw required a shift in how Rsync was built. The development process moved away from its historical culture of careful, human-led stability. Instead, the project adopted a high-velocity cycle of machine-generated code modifications. By treating an automated language model as a substitute for an active human open-source community, the project team compiled a routine security patch with subtle, invisible errors, turning a routine update into a global supply chain failure. The AI was specifically tasked with patching a time-of-check to time-of-use race condition. This is a timing vulnerability within Rsync's background operations that occurs when a system verifies a file path, but the path is manipulated before the system can actually write to it. Rsync legitimately checks a location, verifies permissions, and approves the transfer. But in the microsecond before the write, an attacker swaps the directory for a symbolic link. Rsync blindly follows this redirecting arrow, crashing into system files and overwriting them with the attacker's payload. The AI drafted a patch that successfully closed this specific temporal loophole. However, the model lacked a systemic awareness of how Rsync's broader architecture functioned, causing it to blindly introduce new mechanical flaws into the source code. Those flaws materialized as severe downstream logical regressions in version 3.4.3. The AI optimized for local syntax to get the patch to compile, but broke the global operations of the software in the process. In this data flow pipeline, the AI changed a critical buffer variable to a constant for type safety. That syntax change unknowingly locks the valve on the data stream, preventing state modifications and causing silent file truncation as data is sliced in half. In this second diagram, we see the fatal error. When the AI hit a compiler block, it bypassed the problem by creating an entirely empty string copy command. Incoming file paths drop straight into an empty void, effectively turning critical transfer routines into non-operational ghosts. LLMs can solve localized syntax puzzles to force code to compile. But without a contextual understanding of the system's architecture, they cannot predict how those small changes ripple through the software's operational logic. These hidden bugs didn't stay contained to a single experimental release. They spread rapidly across the globe through standard Linux distribution channels, which use automatic backporting mechanisms to immediately push security patches to older, stable versions. Conservative system administrators, who deliberately avoided upgrading to the newest major release to maintain stability, still received the corrupted AI code. It arrived automatically packaged inside mandatory security updates for older Debian and Ubuntu servers. The resulting outages triggered a viral backlash, peaking in GitHub Issue number 929. The thread mapped a bitter debate between panicked enterprise users demanding reliable infrastructure and desperate unfunded maintainers who argued that AI is the only practical way to sustain massive legacy codebases without active community help. The Rsync crisis proved how automated distribution pipelines operate as a global multiplier. A single unverified machine error can be amplified across thousands of systems in a matter of days. This type of automation failure is simultaneously corrupting high-end corporate advisory services. Analysts are utilizing a practice called vibe citing, where language models generate realistic but completely fabricated citations to support professional claims. In late 2025, major consulting firms including EY Canada and Deloitte were caught publishing multi-million-dollar health and cybersecurity reports containing fabricated academic references, non-existent data, and entirely fake judicial quotes. Whether the output is a C pointer or a health policy reference, the underlying vulnerability remains consistent. In both cases, the generative model prioritizes the statistical probability of a correct-looking response over the rigid, factual constraints of the actual environment it's operating in. For IT teams currently dealing with these Rsync failures, the immediate tactical protocol is to downgrade and pin your systems to stable version 3.4.1. To mitigate the underlying symlink race vulnerability in the meantime, manually enforce the directive use true root equals yes in your configuration files. To prevent these silent regressions, open source communities and enterprises are beginning to move toward a standard of limited delegation. This involves using AI to draft and format, while ensuring that any code impacting execution logic is restricted to human-led authorship and review. This necessitates a shift toward source grounding. It's a verification process where every machine-generated line of code or citation must be manually mapped back to a human-validated primary source, essentially forcing the AI's vibe to prove its work against a known reality. In an environment flooded with machine-generated noise, rigorous human verification serves as the final barrier between a stable system and a catastrophic failure.